Hello, today we're going to talk about direct variation. This is chapter 3, section 4 in your book, and you'll find it on pages 182 to 188. Let's get started. All right, so what we want to do today, we want to be able to write and graph direct variation equations, and we want to be able to solve problems involving direct variations. The first part is going to focus on this, and the second part of the video is going to focus on this. All right, so vocabulary for this section. A function in the form y equals kx, which is very similar to y equals mx. All right, essentially slope without the y-intercept, where k is not 0, is a direct variation. All right, and we're going to be calling this letter k the constant of variation. And essentially, it's just the slope of our line. All right, they're the same thing. All right, and we're going to show that when we know it's a direct variation, there's a shortcut for finding the slope, and we call it the constant of variation. Variables y and x are said to vary directly with each other, so if you see this in a story problem, you know that you can essentially find the slope by dividing y by x. Okay. Now, slope and the constant of variation, again, these are essentially the same thing. All right. Actually, we're skipping this slide. Here we go. So, looking at example 1. So, fact, all direct variation graphs go through the origin. So, they all go through right here. All right. And we want to name the constant of variation for the following equation. So, we have this line, y equals 2x. All right. And your book's going to give you 2 nice points. They're always going to give you one of them. So, in this case, I gave you 1, 2. And they're always going to give you the origin. And the whole point of example 1 is to show you why you can use just y over x to find the slope in a direct variation instead of doing y2 minus y1 over x2 minus x1, because we can always use that first point as 0, 0. So I'll show you what I mean. In the last couple days, we've done the slope formula like this, y2 minus y1 over x2 minus x1. So that's exactly what I did here, 2 minus 0, 1 minus 0. And obviously that gives me 2 over 1, which is 2. Okay, so again, the whole point is to get you to see that to get k, which is essentially our slope, we can just do y over x, because these points, this point 0, 0 here, we can always use in a direct variation, which means it's any point on this line, the y divided by the x. The y divided by the x will give my slope. So that's the whole point of example 1. You're going to see a picture. It's going to give you 2 points. You find the slope. They actually show this, but what they're building you to is to understand that the slope of a line that's a direct variation is y over x, y divided by x. All right, so graphing a direct variation. We want to write any slope we see as a ratio, which for the most part, when it's for a fraction, you're already in a ratio. If it's an integer, then we're just going to divide it by 1. So negative 3 over 1 or 4 over 1 is just 4x or negative 3x. All right. We're going to always plot 0, 0. And then we are going to use the slope to get our second point. So I'm going to graph 0, 0 right now. I'm a little off there, but not too bad. So there's my 0, 0. And now I'm going to use this negative 3 over 2x, this negative 3 over 2, to plot my second point. So I'm going to go this way, down 3. That takes care of my negative 3. So 1, 2, 3, forward 2. I'm going to put a point right there. And then essentially we just connect our dots. All right. Now what I'd like you to try is this one. So kind of follow these steps, pause this video, follow these steps. We're going to write the slope as a ratio. So you're going to make this 3 over 1. You're going to plot 0, 0. And then you're going to use 3 over 1 to make another point and connect your dots. All right. So you can pause the video and give that a shot. All right, moving on. Example 3. This is, you're going to see like word problems like this. Suppose y varies directly with x. That's their way of telling you it's a direct variation. And y equals 9 when x equals negative 3. All right. So we're going to write a direct variation equation that relates x and y. So we're going to plug y in for y, 9 in for y, negative 3 in for x. So we're going to have that variable k there. All right, so we have this, and we're plugging in. We know 2 of these 3 variables. We're looking for k right now. So we plug them in. We divide by negative 3. and we get the direct variation is -3, which now we write our equation, y equals -3x. All right. If you get good and you go back to that first slide and you realize that k is just y over x, you can go right to 9 divided by -3 is my slope or my constant of variation, and I can put that into my equation. What most students do wrong here is they get this and they think they're done. We want the equation to find any point, okay? Not just the slope. We want to be able to find any point. All right, and now we're going to use that direct variation equation, y equals -3x, to find x when y is -15. So I'm going to take the -15, and guess where I'm going to put it? I'm going to substitute it for y, and then I'm going to solve that equation to get x. All right, so I have this, -15 equals -3x, divide both sides by 3, and I'm going to get x equals, divide both sides by -3, and I'm going to get x equals 5. All right, so we can use direct variation to find other points on a graph. All right, so example 4. We have this balloon that's ascending 350 feet every 5 minutes. We want to write a direct variation for the distance d ascended in time t. All right, so we want to make that equation, y equals something x. All right, then we're going to graph it on the next slide, and then we're going to figure out these estimates, and you're going to figure out this one. I do this first one for you. All right, so I know that it rises 350, that's my y, in 5 minutes. That's my x. Okay, if you ever get stuck on these types of problems, time is almost always the x-axis, so keep that in mind. If I divide both sides by 5, I get k equals 70. And then my equation is y equals 70x, or y equals h equals 70t if you want to think of it that way. All right, so we're going to keep this equation in mind, and we're going to go to the next slide. So we're going to graph it. All right. Whoops, forgot to get that to fly in. That's all right. So I get my graph going. I'm going to set up my time and my height here, and essentially I'm just climbing the ladder here. So after 5 minutes, I'm at 350 feet. After 10 minutes, I'm at 700 feet. I could have counted by ones, but that gets, for the questions they're asking us, 2,100 feet or 3,500 feet, that gets a little crazy. All right. So we can see though that if we were to extend this out, we could make an estimate about where we would be at, which ends up being about 30 minutes it will take us to get to 2,100 feet. So we look at setting up our equation, plugging in 2,100, the y they asked us for, into our equation, and then we have, when I divide both sides by 70, I get t equals 30. So in 30 minutes, we'll be at 2,100 feet. Now what I want you guys to do is do the same thing for that 3,500 feet. We know our height is 3,500. We know we're going 70 feet per minute. We want to figure out how long it's going to take us to get to that 3,500 feet. All right? And then the last thing I want you to do is work on these problems on your own. This will be what you're working on tonight. I hope this video helps, and I'll see you guys next time.